You don't need 64 bits to store the number 42, so why are you paying for them? Hey everybody, Harold here. Today let's look at how Polars integer data types work and how shrinking them can dramatically reduce the memory footprint of your data frame. In Polars there's a function called shrink that shrinks their data types to only what you need. Let's go over data types a little bit. Memory comparison. Does your integer need all those bits? Imagine we have a Polars data frame with 10 million rows, just one integer column. The data type we choose determines how many bytes are allocated for each value. So, quick comparison, memory usage for 10 million integers. If you store it as PL integer 8 or unsigned integer 8, you're taking up 1 byte, and the 10 million rows is taking up 10 megabytes. If you store it as 16, it's taking up 20 megabytes. 32, 40, and so on up to 128, you're using 160 megabytes when you could have been using 10. So the big takeaway, if your column contains values that fit inside an N32, storing them as an N64 means you're allocating twice as much memory per value as necessary. Polars defaults to an N64, so you may not even know you're doing this. Here's a little comparison chart. So you can see int 8 up to int 128. Now let's show you how you use shrink. In my Colab notebook, I'm going to import Polars as PL and rich import print because I like the way that prints. And let's just create a simple series, say s equals pl dot series parentheses. A is my column header, and I'm just going to do a list of small integers. 1, 2, 3, 4, 5, 6. Okay. So if I print S, I've got a one column data frame with 6 rows, all stored as I64. Now, I64 takes huge numbers. I8 only takes between negative 128 and positive 128. So if you have single digit numbers or anything up to 128, you should store them as an I8. You could individually cast each column. Instead, you could use shrink and it'll choose what you need automatically. So if I say s dot shrink underscore dtype, call it, it's now stored them as a one column, 6 row data frame as integer 8. It shrunk them automatically. So that's pretty cool. Let's see it on a wider application, more comprehensive. I've got a data frame about superheroes with a string, a 1-digit integer, 2-digit integer for score. I've made purposefully 3-digit integers for the wins, and a float for the rating, and a Boolean column for active. I'm going to print the whole thing before and print its dtypes. And then I'm going to use a little polars here. df shrunk equals df dot with columns. Then I have to use a pl lit on the column id dot shrink dtype alias id. I do the same thing for score, wins, and rating. Then I'm going to print after and print the shrunk dtypes. So let's run that one. So before, I have my string, it's I64, 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 float 64, and Boolean. Then I shrunk them, and you can see the smaller numbers went to I8, integer 8. The slightly larger numbers in the thousands and 900s, etc., went to I16. The float 64 shrunk to a float 32, and the Boolean created a Boolean. So that's how you use shrink. And you can see the memory savings could be significant depending on how many rows you have. So again, you're allocating way more memory than you need if you're just letting Polars default to the I64. So that's shrink in Polars DataFrames. I hope you liked this video. If you did, please like it and subscribe, and I'll see you next time. Thanks, everybody.